Alright, hey everybody, welcome to Lecture 3 of the Unit 4 exam, part of the You Should Have Taken Notes lecture series. We're talking about energy transformations today. Isn't that exciting? Super exciting. Last time on the last lecture, if you watched the last lecture, we went over the different forms of energy, which were mechanical, thermal, chemical, electrical, and radiant, and how they are and what types they are. Now we have to go over what that has to do with energy transformations. The key thing to remember here is the law of conservation of energy. Right over here. The law of conservation of energy is just like the law of conservation of matter, except it uses the word energy instead of mass. Energy can neither be created nor destroyed. It always just exists. It just changes what type of energy it is. But in a closed system, that energy has to go somewhere. So we're going to talk about a few energy transformations. I have up here, I have a motor. A motor is when you are turning electrical energy into mechanical energy. I have a solar cell, the things that you might be putting on your house right about now. A light bulb, for when you have an idea. And a generator, which is the opposite of a motor. So, before going over this, I'm going to show you what a blank one looks like. You just have arrows, and you're going to write what type of energy transformations happen. So, motor. A battery has stored energy, energy that is being stored inside of the acids inside the battery. That is chemical. Batteries have chemical energy, so we're going to start with that. Use some, I can't fit the whole words, I'm just going to write chem. You don't know what chem is, that's chemical. Then, this wire is the electrical energy. Once you've connected it up to the battery, it's turning it into electrical energy because the electrons are moving. And then the electricity is causing the motor to spin. And that motor spinning, because its movement, is mechanical. So there you go. You have the first energy flow diagram, how energy flows from one step to another. The next one is the solar cell. Solar cell is radiant. It is light energy. Radiant energy hits the solar cell, and the solar cell turns it into electrical energy. I can fit the whole word, so I did. It's that simple. Let's go on to the next one. Light bulb. It starts with the battery. What did I say batteries had? I said they had... You can't answer. You're on the computer. They have chemical. The wire turns it into electrical. And then the light bulb creates radiant. Using the wrong color, I chose orange for radiant. It was the closest to like yellow, except for yellow. Yellow would be the closest. I don't have yellow. Generator. Generator starts with mechanical and ends, chose the wrong colors again, with electrical. You might notice something though. So this is the basic energy flow diagram. This is what you are looking for. A light bulb creates light because that's what we want it to create. But there are a few things that these create in addition to what we want. The big one here is thermal. Thermal energy is created and tossed out into the atmosphere in all of these, which is why the amount of energy at the beginning is not the same as just the mechanical at the end, because it's releasing thermal energy as well. So here, when the battery is hooked up to the wire and then the fan is producing mechanical energy because it's moving, but the friction of its parts are also causing thermal energy. So all of these shoot off thermal energy into their surroundings. This is important just to remind you that energy is not created nor destroyed. It doesn't end here. That energy goes somewhere, usually in the creation of heat. Or in the case of the sun, that heat comes from the sun as well, and just a few of that light energy is hitting the solar cell, not the thermal. Or with the light bulb, where light bulbs actually create a good amount of heat, just not as much heat as they produce light. So we look at light bulbs for light, not for their heat. So remember, in the end, thermal is created by all of them, but it's not going to be what I'm asking on your quizzes. I'm going to be asking for what we intend for them to create. We don't intend for there to be heat coming out of this fan. You usually use fans to get cool. We do not intend for the heat. We intend for it to move, the mechanical. So on your quizzes, I'm not going to ask for the random thermal energy thrown off into existence. I'm asking for what we have created the device to do and what that energy is for. Hopefully this all made sense. Yes? No? Talk to me in class.